Later that evening, as Red contemplated going to sleep beneath the stars of a brand new world, another of the siblings sought her out. Little did she know it at the time, but their conversation would open a whole new world to her.
I want to show you something, Red. I think you might like it.
It's not another machine, is it?
No, this is completely handmade. My parents gave it to me. This is a Russian Matryoshka doll. From the outside, it looks like a toy. But inside, it's got layers.
That's amazing.
I know, right? The engineering on this is extraordinary considering it was created by more primitive people. But it's not just about the engineering. These dolls are a great way to think about the field of artificial intelligence.
You and your family take everything beautiful and reduce it to its most practical form. And it's always about machines with you. I want to talk about the beauty and creativity of the paintings on those dolls. Tell me about that.
Hear me out for a moment. I love beauty and creativity just as much as the next person. I'm trying to show you these machines can help us to create more of the good and the beautiful in this world. But we can't get there if you don't understand AI's most basic principles. Let's make a deal. Like I said, these dolls have layers or secrets hidden in plain sight. I'll share some of that with you. But first, you have to listen to my explanation about how these dolls can help you understand the field of artificial intelligence.
Go ahead.
Great, let's do this. Doll number 1 is the father of them all, artificial intelligence. AI as a field covers all technologies that allow computers to mimic human intelligence, from basic software to complex systems like LLMs. Inside the AI doll is doll number 2, which is machine learning. Machine learning is a branch of AI focused on the idea that machines can actually learn from data, identify patterns, and make decisions with minimal help from humans. There are several types of machine learning, each with different approaches and applications. The easiest way to think about it is with an example. Let's say I wanted to teach you how to drive. I could opt for supervised, unsupervised, or reinforcement learning. In the first approach, I opt for supervised learning. I provide feedback and correction, and you begin to understand what to do in different situations. Supervised machine learning is similar. Humans oversee the process by labeling data as correct or wrong and feeding those examples to the algorithm. This way, the AI learns what's expected from hours of training on this labeled data. Supervised learning is the most common form of machine learning, but there are other options. Let's take a different approach with your driving lesson, unsupervised learning. Unsupervised learning would be like putting you in the car without any guidance or rules. You'd have to figure out for yourself how the car works by experimenting, finding out what the buttons and gears do and how the steering wheel affects the direction the car is going in. You'd start to recognize patterns in the way the car reacts under different conditions. In unsupervised learning, the algorithm tries to make sense of the data without any explicit instructions or labels. The third approach is kind of a middle ground between the two. It's called reinforcement learning. It would be like teaching you to drive by using a system of rewards and penalties. Every time you make a correct turn, follow traffic signals, or use the brakes appropriately, you'd get points. And every time you ran a red light or went faster than the speed limit, you'd have points deducted from your total. Over time, you'd learn to maximize your points by driving correctly. In reinforcement learning, the algorithm learns from the consequences of its actions rather than from direct instruction. It knows that the objective is to maximize some type of reward, and so it begins to learn which actions lead to getting points and which actions result in getting demerits. By maximizing behaviors that lead to points, it improves over time.
You're incentivizing machines to take decisions that will maximize points. But who decides what points a particular action receives? It seems like an easy way to reinforce biased systems and biased thinking. And you say that you're training these machines to think like humans. But humans are forced to balance competing interests and make difficult trade-offs. We have to live with the consequences of our decisions. This is not human thinking. You're giving machines all of the power and none of the responsibility for their actions.
You raise some valid points. I'm not going to deny that. But we are working to solve these issues. The reward system can introduce and perpetuate biases if it's not carefully managed. That's why it's important to work with diverse teams and to be transparent in how these points are being assigned. Plus, we have to constantly monitor these systems and adjust them as necessary. And human decision-making does involve a complex mix of emotional and ethical considerations that are not as easy to quantify as the logical aspects. We're working on multi-objective reinforcement learning, where the system optimizes for multiple, often conflicting, objectives. This approach better simulates the trade-offs humans make, and it can lead to more balanced decision-making. But most importantly, I want to add that reinforcement learning is still subject to human intervention and oversight. We don't just let these models have free rein. There's more I could add, but I want to complete our discussion about the 3 remaining dolls. Doll number 3 is deep learning. In deep learning, we train computers to recognize and categorize data at superhuman levels, like identifying faces in photos or picking out voices in a noisy room. Deep learning uses systems called neural networks, which are inspired by the human brain. Just like our brains have neurons that connect to help us think and learn, neural networks have layers of digital neurons that process information. Think of each layer in a neural network as a filter. When you give the network an image, each layer looks for different things. The first might find edges and colors, the next might see textures and shapes, and deeper layers might start recognizing whole objects like trees, faces, or cars. Nested inside the deep learning doll is doll number 4, generative AI. Generative AI models are considered general-purpose technologies. They are about as versatile as electricity, which means they are capable of powering not just one application, but a multitude of different applications for different uses, whether we're talking about text, images, movies, and more. Generative AI can create new content by learning from existing data. For example, if you feed it thousands of pictures of cats, it can generate a new, unique image of a cat that doesn't exist in the real world, but looks convincingly real. This makes generative AI particularly useful in the creative fields. And inside the generative AI doll is doll number 5, large language models. LLMs are a breakthrough technology because they can do so much, and you don't need to learn specialized computer programming tools to use them. The fact that they speak and understand natural language makes them accessible to almost everyone in the world. The language part of large language models is really a misnomer. These models can do so much more, from solving math problems to generating computer code. What's even more amazing is the emergent properties LLMs are starting to demonstrate. They are learning to do things we never taught them. So that's a little bit on how Russian Matryoshka dolls can help you understand the field of artificial intelligence. What do you think?
No matter what you do, these machines will never be humans. You know that, right? I think you're trying to create sentient machines.
There are some researchers who are exploring what's called artificial general intelligence, or AGI. That's probably the closest thing to sentient machines. But AGIs don't actually exist. What we've created is something called narrow AI. These systems are designed to perform specific tasks such as language translation or image recognition, or just play games. They do not possess the general cognitive abilities that humans do. Even if we do eventually create AGIs, it doesn't necessarily mean the machines will be sentient. AGIs are about creating more adaptable and intelligent machines. It's not about giving them consciousness.
You promised to talk about the beautiful paintings on those dolls.
And I always keep my promises. Most people don't know the paintings on these dolls often depict scenes from fairy tales. This one is an old Russian story called The Tale of the Fisherman and the Fish. It's one of my favorites. Would you like to hear it?
I love stories. They tell you a lot about people and their culture. Please share.
Genera, draw an image
You
of...
don't need a machine to tell a story.
It's easier to visualize the scenes with Genera's help.
I can visualize with my own mind. Thank you very much.
Okay then.
Once upon a time, in a land far, far away, there lived an old fisherman.